my name is Shruti and I'm originally from India. I did my studies in India. I did undergrad in computer science and then I moved, I worked in India for 3 years as a QA engineer, and then I moved to Japan where I worked for both engineering and non-engineering roles. As for engineering, I worked as a project manager and QA. So because I explored project management and QA of IT industry, I wanted to explore about development, and I decided to join Code Chrysalis, and here I am today. Here's my LinkedIn and GitHub if you want to see. Okay, so let's get started with React Native. So what exactly is React Native? So React Native is an open source JavaScript framework that helps you to write the native mobile apps. And it was released in March 2015, and it is developed and maintained by Facebook. So when I say it's a JavaScript framework that helps you write native apps, I mean that you write your code in JavaScript, but what it gives you is the native, like what you get in for Swift in case of iOS, and like Kotlin or Java in case of Android. So the end product is native. It's not 100% native, but it's a native-like. So native, yeah. So here are some of the major players in the market who use React Native. So as you can see, there are some big names here like Facebook, Skype, Instagram, and yeah, they do use React Native. So it is a cool technology to learn. So in order to get started, if you are an experienced developer, then of course you can set up your own repo. You can set up your own Webpack, Babel and stuff. But if you are a beginner, then there are two types of scaffolding that are available on React Native official website. One is Expo CLI and another is React Native CLI. So what is Expo first? So basically Expo is a third-party SDK that you can use for developing the React Native apps. So what is the difference between these two CLIs? In case of Expo, you have a single code base for iOS and Android. But in case of React Native, you have two different folders. So in case of React Native, you don't write all the code separately for iOS and Android. Most of the code is common, but if there are some features which are very specific to iOS or Android, you might want to write them separately. So in that case, you have to use React Native CLI. You cannot use Expo CLI. So there is some limitation features with Expo CLI, but depending on your needs and your experience, you can choose whichever CLI you want. Expo is more beginner friendly as compared to React Native because it's just one thing that you have to maintain. So depending on your need of your project and your experience, you can choose whatever you want. So once you have your repo, then you have to start developing your app. So React Native is based on React, so it also has components. By components, I mean that everything that you see on the screen, like a text, image or a text input, is basically a component. It's based on React, if you know React for web development. So here are some of the basic components which React Native has. It's like text input, image, style sheet, scroll view, view. So let me give you an example of one of them, like image, of how you will insert an image in a React Native app. So it's very easy. You just add an image tag and write the source of that image, and it will give you an image on your screen. So it's like adding any component is very easy. You can just write it as a tag, and there are some properties with that tag which you can specify and get your component on the screen. So these were like some of the very basic components. Now let me introduce some of the components that a user needs for interfacing with your app. So like a button, a picker, by picker I mean like a drop down, a slider or a switch. So these are also some of the ready-made components that you have in React Native that you can just use in your app. So let's see how we will add a picker maybe. So here is an example of a picker. So you just add a picker tag and then you specify the picker items, like what items you want in the drop down, and it will give you a picker like you see on the left side of the screen. So basically it's very easy, you don't have to write anything custom. It's all these are pre-made components in React Native. Then some are for list view. So if you have a long list of data that you want to show, then you can use these two components, either a flat list or a section list. By flat list, it's like flat, there is no sections in it, and if you want to divide your data in different sections, like different subjects or whatever, then you can use a section list to make different sections. So let's see how you will add a flat list. So you add a flat list tag, and basically you give all the data that you want to see in that flat list, and it will give you a list like this. It's not divided into section, but if it would have been a section list, you can divide it into like different sections as well. But in case of flat list, you just write all the data and it will give you a list. And you can also specify using item separator component, how do you want to separate those items in the list. And here I have used like lines to separate each of the items, horizontal lines. Then here are some of the miscellaneous or the other components that React Native has. So for example, activity indicator, alert, camera roll, animated, clipboard, dimensions, etc. And adding them is also very easy. You just add the tag for these in your code and you will get something. So if you want to add this activity loader, which was there a few seconds before, like this, you can simply add this tag activity indicator, and it will show that activity indicator. So you don't have to write any animation or stuff to show that. You can just simply use this tag directly, say this component directly. So this way adding components is very easy. These were some of the components which I introduced are like from the native React Native, basic React Native. But there are many third-party libraries out there in the market that have more fancy components or more, I would say, stylish components which you can use. But these were from the React Native. So once you have your components, you might want to make them look better, or you might want to style them. So let's see how you do the styling in React Native. So styling in React Native is based on CSS. It's not very difficult. So for example, you attach a style sheet to each of the component, and then you specify the properties, like how you want to style the components using the properties what you have in CSS. The only difference is it changes from kebab case to the camel case. So background dash color changes to background color, like background's capital C color, as you can see here. So yeah, so this is the basic difference, how you specify the properties, CSS properties, and specify how you want the component to look. So you can use background color, font size, font weight, text size, or whatever you want. So it's similar to CSS. Then you have something called Flexbox in React Native. It's also there in CSS, but if you're not aware of what exactly is Flexbox, Flexbox is like flexible box module. So it allows you to flexibly it allows the parent component to say how it wants to its child components to be placed within itself. Like, so you can specify the parent component can specify how the child components can be placed within it. It should be row, column. We'll see in a minute. So here are some of the Flexbox properties that you can use, like flex direction, justify content, align items, flex wrap, and align self. So let's see flex direction. So with flex direction, you can specify how the child components should be placed within the parent component. If you specify flex direction as row, then all the child components will be in a row one after another. And if you say flex direction as column, then all the child components will be in like this, one after another. So this is how you can easily place your components within your screen or app. Another example is align items. How the components within the parent component should be aligned. Should it be like left aligned, right aligned? So if you want them to start like to be left aligned, then you can use flex start. If you want them to be on the right, then you can use flex end. And if you want them to be center aligned, then you can use center. And if you want them to stretch out to the entire width of the parent component, then you can use something called flex stretch. And then you have something called flex wrap. So if you want the components to be wrapped within the parent component, like not to overflow out of that component, then you can use a property called wrap. And this is on the right side, there is an example of no wrap. So it just overflows out of the component. So this is how you use Flexbox for the placement of the components in your app. Then because you specify the style sheet for each of the component, so there could be a lot of repetitive code. For example, in your entire app, the background screen, like you want it to be black, so the background color will be black. So you have to specify for each of the component. And also like if the text size, you need the text size to be consistent within your app. So if you don't want to remember the exact number that you are using, like for the small text or for the headings, then you can specify something called theme variables on the very top of your directory. So basically you can specify, if I use like small size, it should be 12. If I use big size, it should be 16, something like this. And you don't have to specify the exact number within each component. You can use these theme variables. So if you want a small text, you can just use font size small. If you want a big text, you can just use font size big, and it will give you the text of that size basically. So this is how you can specify the theme variables in React Native. So once you have your components, you have styled them, so you have your basic layout of your app, and now you want the user to interact with them. So in case of mobile, how user interacts with the app is through touches. So handling touches is very important, like how your app handles the touches. So in case of React Native, there are some things like which you can use to handle the touches, and let's see how are they. So first touch that you do is like the very basic touch, that is like tapping on any button or any link. So as you can see in the GIF here, you are just tapping on any button. For making a button or a link, you can use a component called Touchable Highlight to so if you have a touchable highlight component, the user should be able to tap on those component. Then the next touch is basically scrolling. So a user can also scroll on the component either horizontally or vertically. So if you want the component to be scrollable, then you can use something called scroll view, and you can specify the property if you want it to be scrollable horizontally or vertically. And if you have this scroll view basically, then user will be able to scroll it. Then there are some complex touches. So by complex touches, I mean multiple touches. It just doesn't involve just one touch. For example, dragging from one place to another, or zooming in or zooming out. So in these kind of complex touches, basically there are many things that component needs to know, like how much distance your fingers has moved, and also when it is being released and all those stuff. So for that, there is something called pan responder in React Native that you can use. And pan responder has actually 5 methods that keep a track of like how much distance your fingers has moved, and what exactly the component should do when the touch is released or touch starts. So all those things, those methods you can use to handle these complex touches, or I would say multiple touches. So this is all about handling, how do you handle touches in React Native. So next is navigation. Actually, when you make a mobile app, it's very unlikely that you will make a single page app. It's gonna be like, it will have multiple screens or multiple pages. So there should be some way to navigate from one screen to another. So let's see how you do it in React Native. So on the official site of the React Native, basically there are two packages that are mentioned. One is React Navigation and another one is React Native Navigation. So what is the difference between these two? In case of React Navigation, you have like a common stack for iOS and Android. So common code basically for iOS and Android to handle the navigation. But in React Native Navigation, you have to maintain it separately, like how it, because the navigation is natively different in case of iOS and Android. So if you want the exact native feel, then you have to use the React Native Navigation. But if you want to like code fast and you are okay with the same kind of navigation on Android and iOS, then you can use something React Navigation, which is more beginner friendly, of course, because it's single code base for iOS and Android. So with both of these, actually you can do three types of navigation. First is stack navigation. So what is stack navigation? Is basically you create this stack of screens, so and you move from one screen to another in the stack, and the stack keeps a track of the screen behind it and in front of it. So you can move from that screen to the screen one bottom of it or one top of on the top layer. So this is what is stack navigation. Next is tab navigation. So what exactly is tab navigation is, in this case all the screens are loaded actually, but you can just move from one screen to another using the tabs, which are mostly at the very bottom of the screen, and this is I think most common. You can use you can see in Facebook and LinkedIn, and I think many apps use these days this tab navigation. So yeah, and the third one is the drawer navigation. So in this, the links to all the screen is in the side drawer, and if you just like see that drop down on the side drawer, you will see the link of all the screens, and you can decide which screen you want to go from that side drawer. So this is called drawer navigation. So this is all about like how do you handle touch, or how do you make your app, like how do you add components, style them, then how do you handle the touches, and how do you do the navigation. Now all this time I have been saying that you use JavaScript to get the native components. So basically how this happens, you have some, for each component that we studied, there is an equivalent native component in React Native. So basically it has two threads or two modules, like one is native module and one is JavaScript virtual machine, and they communicate with each other using a bridge that is written in C and C++, and these two communicate with each other so that you can write in JavaScript, but what you get is the native components. So the communication between them is asynchronous, so it's very fast. Here is the workflow of how it happens. So once you write your code and you compile it, then it's bundled, and at that time the native module tells the JavaScript virtual machine to run that code. Because JavaScript virtual machine runs that code, it has all the logic of how the app should work, or how the component should render on the app. So the JavaScript virtual machine tells the native module one by one to render the components, and depending on the JavaScript virtual machine instruction, the native module renders that component or do that whatever the JavaScript virtual machine says, and then sends back the response to the JavaScript virtual machine. So in this way, these two things coordinate with each other and like show you the native app. So of course, when you use React Native, you have some pros and some cons as compared to the native app. Like what you write in Swift in case of iOS, and Java or Kotlin in case of Android. So what's the pros and cons? So the first pro is basically, first of all, if you know JavaScript and React, it's easy to get started with React Native. So you don't have to learn any other language. Then it has something called hot reloading. So what I mean by hot reloading is like when you develop and you save your code and it automatically reloads your code. So it makes your developer experience very user friendly, like very developer friendly, that you can just see the updates while coding. So first is this. And then it has a strong community because Facebook is a big company, and also React is very popular in web development. So React Native is also very popular. So there's a huge community, and there are a lot of packages coming out in the market like very frequently. So there you can just use them in your app to make a app quickly or like more pretty or whatever. So yeah, and then that's why there are too many ready to use components that you can use, and it targets multiple platforms. So it targets both iOS and Android, so you don't have to write the separate code, or you don't need to learn 2 different languages in order to make an app. And then some of the cons. So basically React Native itself has very limited components. It doesn't have many components. So the problem is there are third-party libraries, but it's difficult to decide like how are those libraries. Like if, for example, if there is a library for picker, there are 5 libraries. It's difficult to decide which one is better and which one is like not so good. Like so as a beginner, it becomes like a bit tricky to choose like if I should use a third-party one, or what should I do. So yeah, that's the biggest problem. And if you don't know JavaScript, then the learning curve is very steep. And if you don't know JavaScript, then the learning curve is very steep because you have to learn JavaScript, and then also it's based on React, so you have to learn the React principles as well. And then it's not purely native, it's native, like they say it's native but not 100% native. So yeah, that is another. And the component quality differs depending on like which library you use for components. So these were some of the pros and cons. Then while learning React Native, actually I did a very small project just to get started and to learn about it. So I'm going to demonstrate that to you now. So here's the persona of my project. So this is a guy called Joe, and he is new to Japan, and he doesn't know Japanese, and maybe he's stuck at a station and he needs help with the translation. And this is a guy named, let's say, Tim, and he's bilingual, living in Japan from a long time, and he's open to help people who need help with the translations, like some very short translations. Like, so I made an app called Trans No Late, basically trans as soon as possible, like no late, and in which people who are bilingual can register, and people who needs help can log in and see who all are online, and they can just check their profile. From their profile they can take their phone number and call them. Because they are online, it's high likely that they will pick up your call because they are active on their phone. So for making this, I used this architecture. So I have React Native app, then I have Express server, and my database is PostgreSQL. And for authentication purpose, I'm using Firebase authentication. And in order to get the online users, I'm using Socket Io Middleware. So let me demonstrate my app to you now. So, okay. So I'm logging in as Joe now. So, and I see, okay, Tim is already online. So I can go to his profile, check his phone number, and call him from my phone basically. And if I want to give reviews, then I can just add review. can check like the previous reviews as well, like how this person is with translation, like if it is a fake person or something like that. So there is a review section as well. That's it about my app, and you can log out basically. And that's all about it. Thank you so much. And here is a QR code of my app that I made. If you want to check it out, you can go to Expo and check it out. This is also the link. And yeah, that's it. Thank you.
4 years ago here. I worked as an English teacher. I was freelancing in my spare time. So I decided to further improve my skills and I joined Code Chrysalis. I'm originally from Romania, but I've lived in other countries throughout the years. I owned a grocery store in Spain. I managed it for 5 years. I was a training instructor in UK at Bernard Matthews. And now I'm a software developer here in Japan. If you know any job openings, please let me know. I'm looking for offers. But I'm getting off track here, so we should start. Today we're going to talk about Ruby on Rails. So first, what is Ruby on Rails? Well, it's an open source web framework written in Ruby programming language. What is an MVC? Well, an MVC stands for Model View Controller, and what that is providing data structure for the database, web services, and web pages. But do we really understand it? No, I think in order to really understand it, we need an example. So let's say a user will make a request in the browser. That request will be handled by the routing, and the routing will determine the controller. The controller works exactly like the name suggests. It controls both the model and the view. The model is the one responsible for maintaining the relationship between the database in your application, the data in your database in your application, and the view is the visual layer of your application. It determines how the data is structured and how the user see it inside your application. And then from the view, your user sees your page. What makes Ruby on Rails really special is its two key principles, and that is don't repeat yourself, which stands dry, to be dry, and Ruby on Rails actually helps you do that. It's configured in such a way that you don't have to think about things. It already has configuration of the files in a conventional way, and you can build strong and robust applications without writing less code, but do more. So let's see what is convention over configuration. That it's actually, everybody says it's the Rails way. Well, the whole application, like I said, the file structure is built in a conventional way. Ruby on Rails is structured in such a way, in a conventional way. The views, the controllers. But what is really special and I really like about Rails, it comes out of the box with scaffolding tools, and we see that in a conventional way. If we want to make a table for our database, we will supply this command, and by convention we know that the table name should be lowercase and plural. And Ruby on Rails does that for us. You don't have to think about it. He already sets it lowercase and plural. He basically knows English. How can you start using Rails? Of course, you will have to install Rails on your computer, right? You can do that with the gem install Rails. And with this command, Rails new blog, start your server, and yay, you're on Rails. Literally on Rails. Okay, so let's see a little bit of the file structure. This is what you get out of the box. When you first start your Rails app, you specify the name of your app, and this is the file structure that you get, and everything inside it. If you would want to make a new page in your application, you will just need this command, Rails generate controller, and it will automatically create your page, tests page, helpers, style sheets. It will also have routes for that page. Everything is done for you, so you will just think about writing the code, not configuring anything else. I also built an app. In 3 days it took me to build this app. I'm listing cryptocurrency information. I'm searching information on an individual coin, user creation and authentication, storing and calculating your own coins. This is the link if you want to check it out. But let's see it in action. So there it is. It has user identification. So let's log in. I have my user there. We have flash messages. We are able to search for different coins. And you can see here the display. We are able to store our own coins if you want to. If you have Bitcoins or any other coins, you can store it yourself here and will automatically make a calculation of profit and loss. And it's not just for one user. If I were to make a new user right now, so sign up. Create a password. Of course, it will show the top 100 cryptocurrencies, and if you want to add a coin, we can add a new coin. Let's say I bought this for 6,000, and I have 0.5. Okay, so I can store new coins for different users. And I think that is really amazing. We can also edit our profiles, delete the account, change the password, everything. And all that, I want to tell you a little bit about device, because that's what I used for user authentication. This is the tech I used. So Rails, the coin market cap for listing the cryptocurrency, and Heroin. For the background, I use Particles.js. So the user authentication, of course, you need to install the device, generate the controllers, the views, and then you get all that. You get all this already installed. And that, it's not empty. It has everything, your forms, your flash messages, that is. You have your migration, your database is already set up for you. You just need a little bit of configuration that will be your own configuration for your app, for your own users. And that's it. Also, you would say that that is another technology, right? That's device, but it can also work only with Rails. You can use Rails generate scaffold. You give it your table name, and you specify columns and data types, and it also automatically creates everything. Your forms, the CRUD, right? You can create, read, delete, update. Everything is done for you. Now, even migrations, even migration, as you can see here, the migrations with everything you specified, the name of your table, and the data types and your columns. You don't have to come and go to your models and create the actual model, so after that you have to create your migration and such. No, you just write after that command, after this command, you will just need to migrate your data into the database. Now, let's talk a little bit about the problems and limitations. Well, there are some runtime speed and performance. Yeah, in most cases, that your Rails will face will be linked to the server, but that will only happen if your application will be really, really big and robust and will have to face thousands of users that will make requests to your application. And I don't think that will be the case for now. The lack of flexibility. Well, like I said, Rails is a really opinionated framework, and if you choose to do that, it will be really hard later on to change if your application is something else. Is it okay for beginners? I think it is. It hides a lot of stuff that you don't need to know. It teaches you development best practices. It's a forgiving language for beginners. There's a lot of great resource for learning Ruby on Rails and Ruby. It's a very friendly beginner. But even though it's not required to learn Ruby first time, while your app grows, you will get into problems. You will run into some walls. These are some popular applications built in Rails that uses Rails, that have been built in Rails, and I think their name says it all. Their name says how good this framework is, and that you should use it. The takeaway of this presentation is that if you have to choose a framework to build an app, you should choose a popular framework, a high-performant one, an easy to use, that has great support, it's an open source, and is beginner-friendly. These are a couple of resources that I have included for you to check it out. I hope that my presentation today was helpful for you, and you will consider Ruby on Rails next time you will want to build a web application. Thank you very much for coming.
The next talk is going to start at 2:45. So please, in the meantime, the other talk is still going on. So if you decide to stay here, please be quiet or mindful of your sounds. You can also join the other session.
So good afternoon, everyone. Thank you so much for coming to my presentation today. So today I would like to speak about web components and the Polymer project. Sorry. Okay. So first of all, let me introduce myself. My name is Anya. I'm from Poland, but 9 years ago I came to Japan for the first time. So first I came here as an exchange student from my university and stayed for 1 year, but I loved it so much here that I decided to stay and work here as well. So last 5 years I spent working as an account manager in 2 IT companies. And last year my company asked me, so can I learn a bit about jQuery? And at this time I had no idea about coding. I didn't know what jQuery is. I thought it's some programming language I need to learn. So I applied for online course and started learning by myself. And after a few weeks it became so enjoyable that I just waited at my work just to come back home and study more. And a few months passed and I decided to quit my job and join Code Chrysalis to become a software engineer. So since I joined here, I really enjoyed front-end development, and especially React and Vue, so that's why I chose my topic about web components. So here is the plan for today's talk. First of all, I'm going to explain you what web components are and what technology is involved. Then I will say about Polymer Project, and I will show you how to build very simple web component with it. And in the end, I will speak shortly about the future of web components. So many of you may know, but with JavaScript, every few years we have some new technology and library that's coming out, and everyone starts learning it and use it. But few years pass and there's something new. So you may end up in a place where you have one project built in, for example, React and something built in Angular, and then if you would like to build something else that has a similar functionality, you cannot really reuse the things that you built in there, because with different frameworks you cannot reuse the components between them. So web components that I would like to talk about today are a kind of solution to this problem. So what are web components? So web components are very small reusable blocks of UI that are built only with HTML, CSS and JavaScript. And they have all the stylings and all the functionality encapsulated inside. And you can build your own HTML tags and use them as a puzzle pieces on your website for many of your projects. Also, a very cool thing about web components is that you can use them basically everywhere at the moment. So here is the current browser support for web components. And as you can see, Chrome, Opera, Safari and Firefox, they all support every functionality. And of course Edge is not supporting, but there are some polyfills that you can use, and so you don't have problem with Edge as well. So first of all, I would like to say what web components are actually. So this is kind of an umbrella term for the set of browser standards that work together building the web's native component model. So here are the 3 main standards that web components are using. They are built to work with each other, but you don't have to necessarily use everything when you build web components. You can only use, for example, custom elements and shadow DOM, or HTML templates and custom elements. You can mix and match this. So first I will shortly explain about the shadow DOM. So shadow DOM sounds like a comic book character name for me, but when I started researching it was something a bit different. So it's kind of an encapsulated DOM tree that you can attach to your DOM and hide all the functionality inside, so it doesn't affect your project. And this is how it looks. So as you can see, here is your DOM tree that you have, and if you attach the shadow DOM inside, this piece becomes the shadow host, and you have shadow root as the top part of your shadow DOM. And in this shadow DOM, you can have all the CSS and some functions that won't affect your normal DOM. You cannot see it from the outside. So it's very good to help you with JavaScript and CSS collisions. And actually, you may have already used Shadow DOM in your project if you use this video tag in somewhere on your website. So if you inspect the video tag, you see that you can only see this part. So it has width, it has height, and some controls. But all these specific buttons and progress bar, everything is hidden. So if you went to your developer tools and check this Shadow User Agent Shadow DOM checkbox, and go back to the video tag, you can see we have the shadow root actually here already, and all the functionality you can see now. So what are the advantages of using Shadow DOM in your projects? First of all, you have this isolated DOM, so as I said before, it doesn't affect the DOM tree that you already have. You can make very simplified CSS because you can choose better class names and better ID names, knowing that maybe if it's defined somewhere else, it won't change the styling there. Your project becomes much more manageable if it's built with smaller pieces. And also it increases productivity because if something breaks inside, you know that you can look in the side of, for example, Shadow DOM, and you don't have to, it won't affect the outside. So the second technology that Web Components uses is custom elements. So with this, you can define your own HTML tags and use it in your projects. For example, let's imagine that we want to make my to-do tag. So first of all, I create a ES6 class called my to-dos, like this, and I extend it from the HTML element. So this is a native browser's class for the HTML element. And then I make all the functionality here inside, and I define it like this, with my to-dos name. So the rules for defining the name for your HTML tags is that you have to use some name that you haven't used before in your other part of your project. And you have to have a hyphen inside, because the native browser's HTML tags don't have hyphen, and you need this to make it different for the browser. After you make it, you can just use it like normal HTML tag in the project, and you don't need to even import it, it's already visible there. So the third technology is HTML templates. This is very useful if you have a big block of HTML and CSS that you need to use in few places of your project. So here are the two tags that are often used with as a HTML template. There's the template tag that's it encapsulates this big chunk of HTML that you can use in a few places, and it's invisible for the browser at first. So unless you put it somewhere, you don't have to worry that it will be parsed a few times by the browser. And there is a slot tag that, for example, if you build your own web component, you can put this slot inside like this, and for the user who downloads this component, he can put his own DOM tree inside of this slot. So it makes web components more customizable for the user with this HTML tag. Yes, so if you have this, if you know these three technologies, you have all the tools that you need to actually build web components. You don't need anything else, and just JavaScript and HTML, CSS. So what are the benefits of using web components? So first of all, it's composability and code reusability. So when you compose the application from the smaller pieces of code, it makes your code much cleaner, and it's also easier to maintain, and you have less code that you can reuse more. So your project is more dry, which means don't repeat yourself. Yes, so you don't need to repeat all the code, you just repeat the same component. Yes, as I said, code maintainability, so it's easier to test, easier to maintain, and also easier to upgrade, because if you change something, you change only within the one component, not worrying about the rest of the project. Also, it's framework agnostic, so this is very important, because if you want to reuse the components between different frameworks, you can just build them in web components, And if you have, for example, React project with components, web components inside, and then you need to rebuild it in some different framework due to some business decisions, you can just use the same components without having to write them from scratch again. You can also use the pattern libraries, and here are the two that are most popular. So you can compose your components into UI component libraries and share it between your teams. So thanks to this, you can assure your brand consistency within the company, and if something changes, then you just revise this one component, not search throughout the projects. And last but not least, it's very small learning curve. So as I said, it's just JavaScript. If you know a bit of React, I think personally it's easier to start because the structure of web components is a bit similar to React components, but just with plain JavaScript you can actually build a lot. So now when you know what web components generally are, I will introduce a bit about Polymer Project. So Polymer Project are many libraries and tools and standards for the web developers who want to build a better web. So the stable version has been released in May 2015 by Google, and apparently a few years back from 2015, some Google engineers and developers had a meeting, and engineers asked the developers how they would like to use the web in 5 years' time. And then they started developing the standards to make developers' life easier. So what is interesting about the Polymer project is that they are not really aiming to become the next big framework or library, but they think that in time they will actually disappear and won't be used anymore. So their mission is to promote the use of web components and promote the original framework, the platform which is actually the web. And with building their projects, they are also promoting new standards for the web and making a lot of proposals to develop how web components are built natively in the browser. So once the browser is mature enough to have these web components available and more easy to build, Polymer project won't be needed anymore. So here are some companies that use Polymer at the moment. So here's of course Chrome and Google Earth and YouTube from Google. But you can see also ING and Netflix, Electronic Arts, so many big other companies as well. Sorry, let me drink some water. Yes, also Polymer project until now, they have built almost few hundred web components to this date. And you can find many of them on the webcomponents.org website. So if you're interested in web components, not only from Polymer, but also from other users, please check it out. It's very easy to use, and all components have instructions how to use it. So at the moment, Polymer project looks like this. They have a lot of projects at the moment, mainly the Polymer library, which was the initial library from them. It's already getting old, so they are concentrating now on these two new technologies, which is Lit HTML and Lit Element. And I would like to shortly introduce what it's about. So both of them, the stable version has been released on February this year. And Lit HTML is very simple, modern and fast HTML library. So it allows you to use the JavaScript templates literals like that. And thanks to this, the browser, when it parses it, it knows which pieces are static and which pieces might change in the future. So for the browser, it's very easy to reload only the moving parts without having to reload the whole DOM tree. To show you how it looks, so here is the how React re-renders the page. It's a bit hard to see, but you can notice that the whole tags are actually being reloaded. And also the static part, like this text, it's reloaded every time as well. So compared to this, this is lit HTML reloading the same content, and you can see that only the parts that change, like the numbers, only this part is being reloaded. So which makes this lit HTML library extremely fast. The second thing that Google team is working at right now is the lit HTML. So lit HTML is the replacement for their original Polymer element, and it also uses lit element is the replacement for Polymer element, and it uses lit HTML inside to make it not only easy to use but also very fast compared to the native browser's web components. So to show you how easy it is to make your own component, let me show you my super small component that I've made. So I used this repository, start lit element. I really recommend it because for me it was easier to use than the one that they had on the website, and yes, so I recommend that this repository, also from Polymer, and you can find the installation instructions in there. So let me show you how it looks. Sorry for that. Okay. So I've made a Code Chrysalis web component, and this is how it looks in the browser. It's just one tag. And when you see the website, it's just one button. So let's write something inside. Sorry. Yes. So let's write welcome to Code Chrysalis. And we can reload the page and okay, now we have the colorful text that appears after I've written it. And also if you click the button, you will get some cat and a text. Yes, so let's see how it looks inside. Not the cat, but the browser. Okay, so you can see that this is just the one element. And we have the shadow root that I showed you before in here. But because the button that I used, this one is actually also from the Polymer team. I used their material components library, which is very small at the moment. And that's why if you open the button, you can see that it has its own shadow root too. So that's how you can nest each component inside one another and not having to worry if something breaking. Yeah, so this project is not super useful, as you can see, but let's imagine that you actually had some button with some functionality that you want to reuse in many projects. Or you had some text that needs to be styled in some way. So it's really easy to use if you just make the web components for each of such parts and use them in your projects. So going back to the slides. Yeah, so here's how it looks inside of this. Okay. Yes, so first of all, sorry, my slides kind of stopped changing, so. Okay. So first of all, I've made a Code Chrysalis ES6 class, extending from the lit HTML lit element from the Polymer library. And below I defined it like that for the Code Chrysalis name. And inside of this, you have to make some getters that define which properties will have what type of JavaScript inside. Not JavaScript. What type will be the each of the properties. And below this, I made a constructor and defined, for example, this is the text that you write inside the tag. and the message that appears after you click the button. Also, you just write normal CSS as you would do on your website. And I made some functions to change the colors and made a click event for the button. So this is how the HTML looks in details. So it's hard to see at the moment, but let's see one part at a time. So this is the first part. It's the text that you input inside, but actually I could very easily pass it to the function that I've made and use like this with JavaScript inside. This is the button that I've downloaded from Polymer library, and also here I could attach the event listener with JavaScript directly. And the last part is conditional rendering. So after you click the button, either it's the empty HTML or you can see this GIF and message inside. So this is how it looks. It's very easy to build by yourself, such a small part. So I really encourage you to try and maybe use in your next project if you're building something in React maybe. Yes, and lastly, I would like to talk shortly about the future of web components. So web components are very new technology. They are still evolving, and the community is growing, but it's still, sometimes it might be a bit hard to use because it's not such a big community for React or Vue or other big libraries. But there's many new ongoing proposals now. World Wide Web Consortium has over 600 closed issues at the moment, and also Polymer Project, they just released the lead element, and they have many new proposals like shadow CSS or importing HTML as a module. So they have many new improvements to make it even easier to use. Also some frameworks like Angular, they made their own kind of Angular elements to make web elements better to use in Angular. So is the web component going to replace the React? So I think it won't replace, and even React is addressing this in their own documentation on their website. So they are saying that web components and React are kind of, they have different, they're solving different problems. So I don't think the components will completely replace the libraries, but they have great potential to being incorporated into libraries and to use them together. So I think this is a very exciting technology, and I hope that you got some interest in it and you will use it also in your projects. And lastly, maybe you remember this slide from before. So Edge wasn't supporting everything, but Microsoft just announced that Edge will be built with Chromium, the next version. So with this, we will have full support for the Edge as well. So will get even easier to use web components. So yes, thank you so much for listening. If you have any questions, catch me somewhere. I will still be here until the end. So yes, here my GitHub account if you want to check, and thank you so much.
Alright guys, Yasu and Min, I think we can start now, so give a big hand for Yasu and Min.
Hello everyone, thank you very much for coming today. I'm going to talk about JavaScript library called ML5.js, which is very beginner-friendly machine learning library. Before I begin, let me introduce myself. My name is Yasu. I'm from Osaka, Japan. Actually, I'm the only Japanese in the class this time. I'm a former IT and business management consultant. During my previous job, I have seen many Japanese companies or Japanese business managers doing business overseas or managing people from diverse teams. So I decided to create my own product, and that's why I'm here. And my hobby is traveling. Last year I went to Russia, Irkutsk, the deepest lake, and did the scuba diving in the temperature of -1 degree. Okay, let me start. Today I'm going to talk about 5 things. I will introduce firstly about machine learning, and then I'm going to talk about what ML5.js is, and then I'll explain how to use it and what's the logic behind it, and also next step to be machine learning developer. So let me start. So what's machine learning? This is probably the most famous definition by Arthur Samuels, the ability to learn without being explicitly programmed. Let me give you one example. Here, I painted some famous character on the left. And then, if machine learning knows what Pikachu from Pokemon is, it can draw color based on my paintings. That's how things work. What's the categories in machine learning? In general, there are 3 categories. One is supervised learning, the other one is unsupervised learning, and there's also reinforcement learning. Supervised learning has called classification. It's used to classify images, videos. It also has regression. Estimate price of housing, for example. Unsupervised learning has clustering. It uses, for example, to customer segmentation. Like for example, if you like movies, you are classified as a movie lover, and if you like action movies or other kind of movies. And there's also reinforcement used in game AI. The famous one is AlphaGo or automatic shogi playing, and also used for the self-driving car. Today, I'm going to talk about the supervised learning. So what's supervised learning? Let's compare between traditional programming and machine learning with supervised learning. So on your left side, this is the programming. If it's usual programming, you put data, and there's a logic or function, and it will give you an answer. If you put same data, it's always the same answer. Machine learning instead has 2 main parts. The first one is creating a model. So to create a model, you not only put the data, but also answer, or sometimes called level, and you put 2 things to the machine learning, and a model will be created. For example, if you put the cat image, and the answer is cat, and then you will remember what cat is like. And after that, the model is created. If you put another cat image, it can predict it's a cat. So this is basically the fundamental difference between traditional programming and machine learning. Can you guys guess what 270% is? This is percent from Gartner survey on January 2019. The number of enterprises implementing AI grew 270% in the past 4 years. So it's growing every year. 120K. This number is from Ministry of Economics in Japan. This is not the salary of junior machine learning developer. This is the estimated shortage of AI talents in 2013 in Japan. So if you are a programmer interested in machine learning, it might be a good opportunity to start learning machine learning. Okay, now let me move on to ML5.js. So what's ML5.js? It's a very high level, easy to start JavaScript library for machine learning. It's maintained by New York University, a graduate school, an interactive telecommunication program. This library is not like for serious machine learning programmer and not for business. This is more like a hobby programmer or artist who wants to enjoy and be creative and to do something using AI. And ML5.js is created using TensorFlow.js, and TensorFlow.js is from like TensorFlow. So using ML5.js, you don't have to create your own model. You don't have to program difficult predictions. You can just use it using predefined functions in ML5. So it's JavaScript. So why use JavaScript? The first reason can be because it's the most popular language based on the Stack Overflow 2019. And also using JavaScript, it works in browser. It works, it doesn't use the server's resource, it uses the user's resource. And also for privacy, it doesn't store the information. It can be one of the reasons. And what's ML5? It offers several predefined functions. Let me give you several examples. So first of all, it has image classification and video classification. So if you provide an image or video using web camera, it will identify what's the image or what the video is. Or it has auto sketch. So if you want your machine learning to write a cat image, this using ML5.js, it will start writing a cat. And also they have a text generation function. So it has a bunch of Hemingway, the writer's information. So if you type something, and it will automatically predict what's next based on the way Hemingway wrote. It also has style transfer. If you write, for example, cat, and if you want your cat look like Picasso's painting, you can do that with ML5.js. And also it has object detection. If you ever watch a science fiction movies, it will like in front of the camera, it will detect who is the suspect or what's the object in front of the camera. So those things, these are just one of the examples. There are some other examples. So if you want to check it out, please visit the website. So now let me move on and show you one example using video classification. Okay. So on your right, I will switch on the video. So here, it's me. It might take a while. So now, based on the camera in front of me, it starts classifying, and it says hairspray or motorboat. Yeah, it's a little bit difficult.
Maybe you're
So-
supposed to be behind
so- For example, I show this here. Yep, remote controller 100%. So now it can predict precisely. Okay. Okay, so let me go back. So I just showed you how the video classification work, but how to use it. Very easy, 2 steps. Firstly, you just need to add a script tag in your HTML file. Just copy this line, that's it. The other one, first initialize the image classifier using MobileNet. I will explain what's MobileNet later. So here, now you have classifier. And then make a prediction. So classifier.predict and the image or video you want to classify. That's it. Super simple. But what's behind the logic? Now I'm going to talk about the model. So in my example, I used a model called MobileNets. Let me explain what's MobileNets. It's a pre-trained model created by Google. It uses the ImageNet. It has millions of images. So there's a millions data set. And also to create MobileNets, it added labels. So if it's a cat image, it says cat. And then now MobileNets is created and it can classify 1,000 things. So training a model with answer is called supervised learning, just to remind you. But how does classification work? So let me give you another demo. But before I start, let me explain how things work. So in the screen, I will show the black background and also the white circle, and it will move. How? So I will add new images, up, down, left, and right. And by this, I'm going to do the hand gesture. And then if I do up, the white circle will move. Let me give you a demo. Okay. So now so it's automatically going up, so I'm gonna down. So I'm clicking down. So it remembers how the shape of this image is. Let me go, this is on your right. So I click right, and then now it remembers. And here, go left. So I click left. Okay, going left. And now I want machine learning to remember up, so up. Okay, going up. So if I do this, it's going left. And if I do this, it's going right. If I do this, it goes down. Okay, so how does this work? It uses a classification called KNN. How does KNN? KNN stands for K nearest neighbors. How does this work? First of all, what I used was a video, basically an image. So now first need to transfer image into bunch of numbers. This is just an example. And then based on the image or video in my case, it will find the closest neighbors, meaning closest images that I added. Let me give you another example. Let's say there is already a dog information and cat information. And this is just an example, so the images are here, but please think that these are numbers. And if I add a new image, a brown cat, it will try to find which is the closest image. And let's say in this example, the K nearest neighbors, K is 3, like this. So it will try to find the 3 nearest images. Now this cat is classified as a cat. So this is how my demo worked. So now I have covered briefly about machine learning, how the model works, and also how the prediction worked. But how can machine learn? Cat or dog, up or down? This is the numbers used classifying my next example. So it's very difficult. So let me briefly talk about neural network. They have an input layer, hidden layer, output layer. Well, what is this? Can you remember the weather of all prefectures in Japan? By just looking at this? No, it's difficult. So what's happening in our brain? We try to find a spot to group data so that you can easily remember things. So to find a group with more precise and less errors, it might be like this. So machine learning will try to find a spot to group the data with less data more precisely. So by doing this, in Japan, there are 47 prefectures. Instead of remembering all prefectures separately, you can now remember only 11 by making prefecture area. So how does this work? So there was 47 data points. Each prefecture has weather. And in the hidden layer, there is something happening. And then it became 10 data. I'm sorry, it's 11 data. And what's happening here? Let me give you an example. If you want to remember what's the Tokyo's weather, it was cloudy. By making this 11 data, how can predict Tokyo's weather? So you will look at average and Kanto's data. So Tokyo belongs to Japan, which is average in this case, and Tokyo also belongs to Kanto area. And average has a number 1.2, Kanto has a number 1. In this example, weather, if 0, rainy, 1, cloudy, 2 is sunny. So let's say in Japan, in average, the weather was 1.2, a little bit cloudy. And then Kanto was cloudy. So now what it does is 1.2 plus 1 and divide to make the average, which is 1.1. So now it becomes 1. And because it's 1, it can detect that, it can predict that it's a cloudy. So this is what's happening behind the functions in ML5. And by doing this calculation over and over, it will try to find the best grouping that can return the best prediction. So in my case, I just used, like, for example, Hokkaido, Tohoku, Japan Sea, North Japan Pacific, those areas. But if it's not the good grouping, machine learning will create the other grouping.
Sorry, right. You actually predefine the grouping if you did supervised learning. It's not learning any grouping.
Hey, sorry, no questions.
So, as a summary, I talked about the model, how the model is created in the supervised learning. So to create that, you need to input not only data, but also labels. And once the model is created, using the model, you need to input the data, and then it will output the prediction. And then use the model as a mobile nets, and also I showed you KNN classification. So I just started to learn machine learning, and the next step would be learning the TensorFlow.js, and then you can go ahead and learn TensorFlow using Python. Here is the resources I used. ML5.js. There are some good YouTube resources, and also the Coursera's machine learning by Stanford University. If you can read Japanese, this book was very nice to start with. Thank you very much. If you are interested, here is my application that I showed you today. Thank you.
stage, please.
Yes, thank you very much for coming. And especially everyone who come for the first lecture and stayed all the way to my. I really appreciate it. And yes, today I will introduce serverless and I will be using AWS Lambda. But before I do that, I would like to make a short self-presentation about who I am. So first, as kind of already said, my name is Johannes Jarbrat. And I'm Code Chrysalis student now. I came here to Japan from Sweden just after graduating my Master of Science in Industrial Engineering and Management. And I started working here at a Japanese company, and I worked there for 4 years. I really enjoyed it, and I learned a lot about not only work, but Japanese culture, and something you can't get unless you work at a Japanese company. And I was the only foreigner. And one thing I really learned was that Japanese people love printing papers. And then putting it into the Excel. So they print the PDF, put it in an Excel. And I didn't love doing that, so I started writing VBA scripts and later also Python to automate this process. And while doing that, I discovered how much I love programming, and I thought it was so fun that I decided to quit my job and join Code Chrysalis, and here I am. Yes. So, what will I speak about today? A little bit of contents. First, I will talk about the definition of serverless and what it really is. And this could be a little more vague than some other definitions, but I will do my best. And then I will do a short presentation of why I chose AWS and Lambda to do for this presentation and introducing serverless. And then I will go through the benefits, or some of the benefits with serverless. And I also try to do something myself with serverless, so I will show a really short demo of an application I made. And then I will go into the drawbacks of serverless, because it's not only good, there's also some bad things about serverless that you should be aware of. So, definition, what is serverless? Well, serverless, the word is a bit of a misnomer, and because there are servers. Serverless things are things like cars, shares, houses, things like that, but things on the internet need servers to run. So even if it's called serverless, there's actually a server in the background. So anything without server? No, that's not serverless. But what more serverless is that the customer, the vendor, for example Amazon, who provide this service, for their customer, do not have to worry about the physical server. And not only that, they also don't have to worry about any virtual server, no setup, no configuration, and kind of that, no scalability. So scaling is also something you don't have to worry about when using this kind of service. So no matter how big or small your workload is, you don't have to worry about scalability. And this is an important point. The last one is this is when employing your application on or function to the web. Because if you use internet and don't have to worry about servers, that could include software like Gmail. You don't have to worry about servers or Office 360, but that's not what I'm going to talk about in this. This is more serverless for applications or functions. That's an important difference. So, why did I choose AWS and Lambda? First of all, AWS stands for Amazon Web Services. And is there anyone here who hasn't heard about Amazon? Really? And that's exactly my point. Yeah, and Amazon is one of the biggest web service provider in the world. If they're not market leader, at least they're in the top. And they have a huge library of services. So I tried Google, how many are there? And I couldn't find a number because they are expanding with new services all the time. So I just went in on and calculated them all, or counted them all, and there are over 150 different services. And Lambda is one of the services. They also exist in 21 regions. All the blue dots are different regions, and they have 64 zones. And the zone can be simplified as, yeah, it's a data center. And Amazon Web Services is constantly growing. Not only and the serverless is something that's really growing lately. And not only Amazon, but the market as a whole is growing. So their competitors is also growing on this market, especially Microsoft with their service Azure. If anyone has heard about it. Yeah. So that, but Amazon Web Services is the market leader right now, and that's the reason why I chose them. It only makes sense. Yes. So what is Amazon Web Services Lambda? Well, it's a FAAS, and that stands for Function as a Service. So what Function as a Service can really be said to be is that you can have service at different levels depending on how much you want to do as a customer and how much you want to hand over to the vendor. And first we have infrastructure as a service, and that the vendor only takes care of the hardware and the virtualization, but all the other things is done by the customer. They have to set everything up. And then we have containers as a service. Then the vendor takes care of a little bit more, take care of the operating systems. And then we have PaaS, it stands for Platform as a Service. They take care of a little bit more. And then we have Function as a Service, when the only thing that you as a customer has to care about is running your function on writing your own code. There's also software as a service that's not in this, but that would be, for example, Google Docs or Microsoft Office 360. Yes, so a little bit more. Lambda is stateless, and that means that the software, when you call the software, it wakes up and it doesn't remember anything that has happened before you called it, if it has been called before or not. And once it has finished its work, then it's shut down again and it forgets everything that it has done. But the important thing is that you can have this your Lambda function write things, to example, to a database, and then on startup read from that database. So think about it: if you wake up in the morning and you have or you go to bed in the night and you forget everything you don't write in your diary. That would be a good non-technical comparison. And last of all, Lambda is used as a backend for other applications. And that means you don't put your whole application in something that's function as a service, because that's not really what it's designed for. Instead, you have this as an upload for your application. If there's something especially heavy to run on your server, then you put it in this serverless, and they take care of all of that for you. Yes, and a benefit, I already mentioned this a little bit, but it's scalability. Because maybe your function doesn't take so much hardware, so then you can have what you call a little worker who's do the work for you. And it doesn't get so much specification, but it's cheap to run. But if you have a more heavy-duty thing, you can get a bigger machine. And this is really easy to configure. It's just 2 button clicks, and you can totally change your specs. And you can have even more. But if you get a lot of traffic to your site and you get to run up a lot of functions, then you can then there's automatically horizontal scaling, so you can get another one or another one, 4, 5, 6, and yeah, this is run automatically in serverless. So if your workload increase, you don't get downtime. It just grows horizontally to get the work done. Another benefit is that serverless is quite cheap. And if someone here has used serverless, they might say that it's not cheap, but I will come to that later. But with serverless, because you only run when you only pay for when the function is running. Oh, sorry. So every time the function is called, you pay a little bit, and this is a real small amount. And it's great if you have heavy-duty tasks that are run occasionally. For example, if your application has really high demand in the morning and in the evening, then you would only pay extra money for the extra capacity during this time. But if you weren't using serverless but was paying for a server, then you would have to have this spare capacity all the time, and that would be expensive. So in this case, serverless is really cheap. And the third is time to market. And what I mean with this is, once you get used to the serverless framework and learn how to use it, then it's really, really easy to get your code up and running. So I made a few functions that I put on the serverless or Amazon Lambda. And the first time, then I had to learn how to use everything, and it took a while. It was quite hard. But the second and third one, it got so much quicker, and a lot of things are already preset for you for the first time you set it up. So you can have it running in really no time. And once again, you don't have to configure any servers or any virtual machines, or in Lambda's case, you don't even have to care about runtimes or containers. It's all done automatically for you. It also supports a lot of different languages, for example Node.js and Python, Go, and a lot of other languages are all supported. So, yes, so a use case example could be file conversion. Let's stop this animation. Yes, so for example, if you have a site, let's say a recruitment site where people can upload the resumes, and maybe you want the resumes as a PDF because you can easily distribute it to everyone, but you don't want to limit your customer to only upload files in PDF files. You want to give them the possibility to upload, for example, Word files or open Office documents, and a lot of different kind of documents, maybe even images. And then you want them converted into PDF files. So PDF conversion is quite CPU heavy, and if you get a big load, your system will, it will be all loaded and it will probably crash. Unless, of course, you build out so you have the server capacity to do this. But that would mean that you have all this idling time when people are not submitting their resumes. Maybe during working days from 8 to 12 in Japan. But then you don't get so much, but after people get home from the work and they start submitting, then you need the capacity, or if your site goes down, they can't use it. And this is a perfect place to offload your main server and have this conversion function running in the cloud and serverless. And much thanks to auto-scaling. And that's one of the applications I did. So I refer to this, so demo. So I made this small little file converter. That's this server is running on my local host, but the file conversion is done on the Lambda. So I can choose here to just upload a file and go to, and here we have it. So I'll just convert this file and send it to Lambda and convert it. And then after a while I get this little nice download link. And when I click this here, you can see everything is converted to PDF file here, and you can also see that I have it up on the Amazon sites. So this the file is sent to the Lambda serverless, and it converts the file and then put it into my S3 bucket. And S3 buckets, for those who don't know, it's just a file storing service that's Amazon offering. Yes. So drawback with functional servers and Lambda and serverless as well. One is response time. And what I mean with this is that when you're not using the function, it's not running. So every time you call it, it has to start up from 0. And this response time is, Amazon says it's only 125 milliseconds, but that's also almost 0.13 seconds. So if you have time-sensing things that needs to be done really, really quick, then serverless is not for you, even if it's only happened with irregular cases. And especially if your serverless function is calling some other serverless function, then you get the double response time. And if you call the third one, then it's almost half a second in just getting your functions up and running. Yeah, and this is probably not the problem for most people, but if your things is time sensitive, you should know this. And another one is execution time, or runtime, how long your function can run. And Amazon has 15 minutes is the maximum that your function can be kept alive, and then it's killed off automatically, and it suffers a timeout. And Microsoft Azure has only 10 minutes with a 5-minute standard. And this means that you can't have a long-running function running on your serverless. So that's also something most people will probably not run into this problem, but if you have like huge things you need to be done, then maybe serverless will not be for you. And the third thing that I would come back to before is that serverless can be expensive. So one thing is that to activate your function, for example, you have to use another service to activate your serverless function. And that could be an API gateway, and that one also costs money. And that could actually become more expensive for paying for the API calls than actually having your function running. That's one thing. And another thing, now I blacked out. Yeah, and you also pay for every 100 milliseconds that the software started running. So if your function runs in 40 milliseconds, you pay the same amount as it would have run in 90 milliseconds. It will still be the same price. And also you don't pay when you're not using your function, but when your function is waiting for other function or services to call, to respond when call is made, it means it's still up and running. So if your serverless function calls another function that takes a lot of time to answer, then you have to pay for that waiting time. And that's also something to be aware of, especially if you depend on third-party things to answer. So I did an API call that took 7 seconds to respond, and yeah, that's not really nice. And the fourth one that's really important to be aware of is lock-in when using this kind of services. And everything has lock-ins, not only serverless. If you start using Windows and then start using Office, then you kind of locked into the Office system thing. And the same with serverless. And and there's a few different things to be aware of. One is how you call the function. For example, if once again you call your function with the API call, then different vendors have different kind of APIs. So you might have to rewrite the application calling your serverless function if you move your serverless function. And not only just change the address, call this page instead of this, you might actually have to change how you call it. Another thing with the API gateway is that it's different between vendors how they hand over your call to your functions. So if you choose change vendor, then you might have to rewrite some of your code how it handles the information that it gets from the API or from other services. You can use, for example, events in S3 buckets or other kind of events. And the third kind of lock-in is service integration. So a lot of web service providers, they provide a lot of different services that can be used for data streaming and once again data stream bucket. And when they connect together, you can't just move this serverless function because maybe then to another vendor because maybe then you can't activate it. So that would mean you would either have to move one function, you would have to move all function or no functions. And if you make up a big complicated network of different function calls together, this could be a real headache. So that's also something to be aware of. But once again, lock-in is not a reason to not look into serverless, but it's something to be aware of when you're looking into it. Yes, and before I end my talk, I would like to say that I'm unfortunately not employed at Amazon. So there are a lot of other great alternatives that I want to point out, even though I used Amazon in my demonstration. So for one, there is Microsoft Azure Functions. Amazon Web Services right now have 40% of the market share. They are the market leader in web services. But Microsoft comes in as second at 30%. And they are also growing really quickly, mostly because a lot of Fortune 500 companies in the US have started looking into this and looking into serverless. And they, for some reason, choose Microsoft instead of Amazon. And there's also Google Cloud functions, there's Binaris and eBay Cloud functions. And eBay is actually, their cloud function is built on an open source serverless framework that I feel is really interesting and might be something you want to look into, especially if you're someone who cares a lot about the open source community. Yes, and that's everything to me. Here's my LinkedIn, my GitHub account, and my email. Please feel free to contact me if there's anything you want to ask. We will not have Q&A now, but as soon as I plug in this, you are more than welcome to come up and ask me questions. Thank you very much.